Hey class, today we're on to lesson 4, which is about the distributive property. Please notice that this is part 1, and in exciting news, part 1 doesn't have any letters or variables in it, right? Instead, we are going to see some rectangles. We're going to use a diagram of a rectangle that's then split into 2 smaller rectangles to write different expressions that represent its area. So some of you might be familiar with this depending on where you went to elementary school, and for some of you it's brand new. In either way, it's going to make sense by the time we are done with this, so hang tough. On the right, you can see a grid, and in the grid there is a rectangle. Down and to the left, there's a lot of colors, and these are all expressions. Notice that none of them have an equal sign, right? I don't see anything that says equals. I mean, you could equal them up, but right now there's no equal sign. That's what makes it an expression. No equals. I'm going to write that up on top. We've talked about it in class, but now I really want to make sure you know. All right. At least one of these colorful expressions, maybe more of them, represent the total area of the outside rectangle. So I'm going to trace the outside rectangle in red so you can see it. Down, going to the left, and going back up. So we are looking at this red rectangle. If I wanted to know its total area, I could use at least one of the expressions down below. So when we're talking about area, I want you to see that we're talking about its entire inside space. How many little squares are inside this rectangle? And you could just count them up, but if you just counted them up, you're not going to be able to use any of these expressions. Again, we're not looking for the equals. We're looking for a representation that means the inside space, right? So here's one thing that we could do. We could break this rectangle into 2 smaller rectangles. I'm going to make a pink rectangle on the left, and I'm going to make, it's kind of like a white rectangle on the right, but let's color that anyway, and a yellow rectangle on the right. Here are 2 separate rectangles inside the red rectangle. If I wanted to find the area of each one, I could add them together. Or I could see how many squares are in a row. So let's look at the pink rows. There's a 3 across from left to right, and then 3, and then 3, and then 3. I see repeat addition. So the number of 3s depends on how tall the rectangle is. And that number on the outside tells us how many times the 3 repeats. There are 6 3s going up and down, right? And this 3 on the bottom tells us the distance from left to right. Right. So I could add up those 3s. I could say 3 plus 3 plus 3 plus 3 plus 3 plus 3. Or you just heard repeat addition, which means an expression for the pink part is to make it be multiplication and say this is 6 times 3. That's the pink one. So what about for the yellow one? For the yellow one, left to right is 2 this time. It's 2 across, 2 across, 2 across, 2 across. It just keeps repeating. How many 2s are there going up and down? There's 6 of them. And we can see that on the outside. There's a 6 to the left. That's our up and down number. And then a 2 down below. That's our left to right. So 6 is the height, and 2 is the width. So I could add up all those 2s, 2 plus 2 plus 2 plus 2 plus 2 plus 2. Or I could say that is also repeat addition, which makes that multiplication. There were 6 2s. I saw the number 2 6 times. 6 groups of 2. So this gives us our first expression. This is the green expression over on the side. 6 times 3 and 6 times 2 are both inside that rectangle. Right? That is one way to see the inside area of that rectangle. All right, so let's see if there's another one. we'll look down at the very last one in blue. Right? In blue, I see a 6 on the outside of the parentheses and 3 plus 2 on the inside. So take a look at where that might be in our diagram. I'll make this red part come back. There it is. Right? So here's the 6 that's on the outside of the parentheses. So then what about the 3 plus 2? That's hanging out right here on the bottom. This is the width of our rectangle. Right? So for this to work, that 6 parenthesis 3 plus 2, we would need to see 6 repeats of 3 plus 2 inside our diagram. And I think we can see that. Here's a 3, here's a 2, so this is now 3 and 2, this is 3 plus 2. And that just keeps repeating. I'm going to copy and paste. That repeats in the next row, and in the next row. You can see that it's a repeat because I can copy and paste. So there are 6 repeats of 3 plus 2. This expression right here, 6 parenthesis 3 plus 2, this means 6 times, remember invisible times, I can see 3 plus 2 6 times. And there it is, right inside of our red rectangle. That means the blue one is also a representation. There's one more that works. And the one that works is by now actually adding the 3 and the 2. If I add across, so I'm going to make the 3 and the 2 and this bottom one disappear. If I add across, there's 1, 2, 3, 4, 5. There are 5 going across, which means I could just write like this. And notice 3 plus 2 is 5. That's our 5 going across. So I'm going to replace all of those 3's and all of those 2's and the pluses with this 5 going across. Copy, paste, 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 paste. There. Now, what we have inside our rectangle is 6 repeats of 5. I can see them top to bottom. There are 6 repeats of 5, which means that purple one is also true. Okay, so what about the red one and the kind of orangish one? Well, the red one can't be right because it says plus. So if I had 6 plus 3 plus 2, that would mean individual little squares, right? It doesn't mean inside the red rectangle. If I had 6 plus 3 plus 2, I'm going to draw it kind of out here on the side. I'd have 1, 2, 3, 4, 5, 6 little squares, plus 3, 1, 2, 3, plus 2 more. This is what the red one looks like. It would be this shape, this pink shape over here. You can see that is not the same as the inside of that red rectangle. So I'm going to cross that one out. That one doesn't make sense. But the orange one looks similar to the blue one. So take a look at the difference. If you see the difference here, it's the parentheses. Can I kind of put that in yellow? The parentheses, that's where that difference is. So the difference between the orange one and the blue one is saying we have to do 6 times 3 first. Remember the order of operations? We'd have to do 6 times 3 and then add 2 more little squares. So here's what this one would look like. 6 times 3, you'll remember, is inside the red rectangle. It's hanging out right here. This is 6 times 3. I'll put that back in. This is 6 times 3. But if it's plus 2, then it's just 2 more of these little squares next to it. This is a picture of 6 times 3 plus 2. That does not take up the entire area of the red rectangle. That means that the orange one is also wrong. We had to combine the 3 and 2 and take that and copy it 6 times. All right, so be really careful on those ones without parentheses.